Welcome. In this explainer, we're going to crack the code on a really common AQA chemistry question. It's all about the nasty pollutants that come out of car engines. By the time we're done here, you'll know exactly how to answer it using the official mark scheme's own words. So here's our game plan. First, we'll look at the question itself. Then, we're going to dive into each of the three parts, one by one. And to finish up, we'll do a quick recap of the essential science you need to remember. Sound good? Let's get into it. Okay, let's dive right in. First things first, let's see the question exactly how it would look on the actual AQA paper. So this question, it's all about the chemistry that's happening inside a car engine and the pollutants it kicks out. You'll see it's broken down into three parts, and it's worth a total of 8 marks. That's a decent chunk of your exam, so getting this one right is super important. All right, let's tackle the first part of this question and see how we can bag those first 2 marks. Okay, so the question is asking us about the cause of 2 different pollutants. First, there's carbon monoxide, which is a really toxic gas. And second, solid particulates. You probably know them better as soot. Now, notice it's a 2-mark question, which is a big clue that we need to make 2 distinct key points in our answer. And the secret here is all about one thing: oxygen. Or, well, a lack of oxygen. See, when the fuel in an engine doesn't have enough oxygen to burn perfectly, you get what's called incomplete combustion. Instead of the carbon making a nice clean carbon dioxide, it forms carbon monoxide, or even just pure carbon, which is that black soot. Grasping this idea is absolutely crucial. And here it is, straight from the horse's mouth. This is what the examiners are looking for. For the full 2 marks, you've got to say 2 things. First, you name the process, incomplete combustion. And second, you give the reason for it, insufficient oxygen. That's it. 2 clear points, 2 marks in the bag. Now, for the biggest section of the question. This part's worth 4 whole marks, so it requires a much more detailed, step-by-step explanation. It's all about linking the tiny amounts of sulfur in fuel to the massive problem of buildings getting eroded.
So the key here is to explain the entire chain reaction. You need to connect the dots, starting with the sulfur that's in the fuel, then explaining the pollution it creates, and finally linking that to the specific damage it does to limestone buildings. And this slide lays out that whole cause and effect chain perfectly. The mark scheme breaks it down into 4 crystal clear steps for a perfect score. You start with the sulfur burning, which leads to sulfur dioxide pollution, which leads to acid rain, which finally reacts with and erodes the limestone. You see how each step logically follows the last? And here's a little tip. This comes directly from the mark scheme too. For that very first point, you don't have to use the fancy phrase reacts with oxygen. You can just say sulfur burns to form sulfur dioxide. It's great to know there's a bit of flexibility, as long as your chemistry is spot on. Okay, let's move on to the final part of this question. This one zooms in on another nasty pollutant that's created in car engines, nitrogen oxides. This question really gets to the why. I mean, why do these specific pollutants form in this specific environment? Think about it. The air all around us is nearly 80% nitrogen, and that nitrogen is famously unreactive. So what on earth is so special about a car engine that makes it react?
And there's your 2-mark answer. It's a 1-2 punch. First, you have to state the condition, which is the incredibly high temperatures inside an engine. Second, you state the reaction that happens because of that condition. All that intense heat provides enough energy to smash the strong bonds in nitrogen molecules, which finally allows them to react with oxygen. You need both of those points to get the full 2 marks.
So let's just quickly recap the core science we've covered by breaking down this question. This is really the fundamental chemistry that holds all of those answers together. These are the absolute must-knows. A lack of oxygen gives you incomplete combustion, which makes carbon monoxide and soot. Those sulfur impurities in fuel, they create sulfur dioxide, the main culprit behind acid rain. And finally, that crazy heat inside an engine forces nitrogen and oxygen to react. Understanding these 3 processes is everything. And that's how you break down question 06. Now that you really get the chemistry that's causing the problem, it kind of leads to a bigger question, doesn't it? What sort of technologies, like catalytic converters, do you think we can use to actually solve these pollution problems? Something to think about. Thanks for joining me on this explainer.